This video is on solving systems of linear inequalities in two variables. A system of inequalities is a set of two or more inequalities with the same variables. Its solution is the set of all ordered pairs that satisfy all of the inequalities. To solve a system of inequalities, we want to graph both inequalities on the same set of axes and then determine the intersection or the overlap of the shadings of the two graphs. This is the region that contains the solutions. Let's take a look at an example. Here we have the system of inequalities. 3x minus y is greater than or equal to -1, and 2x plus y is greater than 5. So let's go ahead and rewrite each one of those in slope-intercept form. So for the first one, I'm going to subtract 3x on both sides, and then multiply the entire equation by a -1. And when I do that, I have to flip my inequality here. So that's going to give me y is less than or equal to 3x plus 1. And then my second one, I'll go ahead and write it over here. I'll subtract 2x on both sides. That gives me y is greater than -2x plus 5. Okay, so let's go ahead and graph this one first. Y is less than or equal to 3x plus 1. So starting with my y-intercept of 1 and moving with my slope of 3. Okay, and this line is solid because it's a less than or equal to. And for this line, the shading would go below or on this side of the line. And I'm just going to do that very lightly so that I'm aware of that's the side of the line I'm going to shade. Let's graph my other line. Y is greater than -2x plus 5. So starting at 5 on the y-axis, and my slope is -2, so down 2 and right 1. I'll do several of those. And when you're doing these, the point of intersection doesn't really matter because the solution is not going to be one point, it's going to be a whole region of points. And this is a greater than, not a greater than or equal to, so this one's actually going to be a dashed line. And it's a greater than, so the shading in this case is going to be above the line. And now I want to look closely and see where do those two shadings overlap. So for the dashed line, I'm kind of above and to the right. And for the bottom line, I'm kind of below and to the right. And so they overlap in this region right here, which you would want to shade in nice and dark. So all of this area here is where my solutions are contained. Remember, what that means is that any point in this region works in both of these inequalities. So here's a practice problem for you to try. I'd like you to stop the video and copy this into your math journal and give it a try by yourself. Okay, let's take a look at this problem. So we have to solve this system of inequalities by graphing, and I have x plus y is greater than 2, and -4x plus 2y is less than or equal to 8. So I'm going to go ahead and rewrite each one of those in slope-intercept form. Subtracting x on both sides gives me y is greater than -x plus 2. And for my second one, I will add 4x on both sides and divide everything by 2. And that's going to give me y is less than or equal to 2x plus 4. So I have this one here and this one here. So let's go ahead and graph those. So my first one is going to be a dashed line starting at +2 and having a slope of -1. So I'll go ahead and fill that in. And this is dashed, so I'll add a few dashes between my dots. Okay. And this is greater than, so my shading is going to be above the line, and I'm going to do that very lightly. My second line has a y-intercept of +4 and a slope of +2, so up 2 and right 1, or down 2 and left 1. And this is a less than or equal to, so it's going to be a solid line. And since it's a less than, I'll be shading on this side of the line. And now I need to look at where do my shadings overlap. So for the dashed line, it's kind of above and to the right. For the solid line, it's kind of below and to the left. So I want to color in, shade in this region nice and dark. And that's where the shadings overlap each other. And what that means is that all of the points in that region are solutions to this system of inequalities. So in this video, we took a look at how to solve a system of linear inequalities in two variables by graphing the two inequalities separately, doing the shading, and seeing where the shadings overlap each other.